What I've done is taken these 6 vertical wire coils, wired up with 3-phase power from this little device, starting at 0, and the south poles are pointing out here, the north poles are pointing out here, and it'll spin. And the reason I've done that is when we spin it, hopefully the magnets won't fly off like they did before. So if we spin it at really low speeds, 3 hertz, 5 hertz, you can see it spins very nicely. 5 hertz. Now what I'm trying to do is spin up at higher speeds and see what happens. Okay, now here's the spin up at 10 hertz. Here's the spin up at 20 hertz. Here's a spin up at 30 hertz. At 40 hertz. If I do it too fast, the magnets will fly off. And here's the spin up at full mains power. Watch this. Quite a powerful motor, isn't it? 50 hertz. No trouble with that. Thank you very much. Now when we go up to 6 wire coils arranged in a circle, we can still have a barring magnet pointing that way, north pole here and south pole there. But then we have to put, it won't spin by itself, we have to put 2 helper magnets with, in this case we have both poles pointing in. It's wired as UVW, UVW. Let's turn on 3 hertz and see what happens. Now you can see it spinning around quite nicely. We're going to do almost the same thing, the north pole here and the south pole there. We'll have 2 red poles pointing out. We turn on some power and again it spins nicely, this time anti-clockwise. Now if we again just have 1 row of magnets and both poles are pointing out, both poles in, we can get a slight rotation consistently from the UVW torque with no helper magnets. So the magnet here, each blue magnet is just following the field around, and when we spin it up we can self-start to some extent. That's not the most powerful spin I've ever seen. Next let's add 2 helper magnets around the outside, 2 S poles pointing out, and here we've got 2 N poles pointing out. So you have 2 N out and 2 S out, at 90 degrees to one another. We turn a little bit of power, and now it spins quite beautifully. NS, NS poles alternating out. Can't really get much better than that. There's another alternative. We have 2 S poles pointing out here. We have 2 more S poles pointing out here. So all 4 S poles point out. We put on a bit of power and it spins nicely. Clockwise instead of anti-clockwise. Another beautiful motor. The 6-4 arrangement with all 4 poles S sticking out. This rotor with 6 wire coils vertical and a row of magnets, both south poles out here and both north poles out here, will start quite easily, even at 10 hertz. Start from 0 to 10 hertz instantly. The torque's really, very strong. Watch me when I turn on the power. Now let's start it at 20 hertz. 20. The full power is 50 out of a power supply. Once again, when I take off the 2 helper magnets and just have 2 south poles out, it will spin anti-clockwise in accord with the UVW power, but the 4 magnets is a lot better. This is trying to start, say, at 10 Hertz. It will spin up, but it's ragged. Okay, let's just summarize what we've learned here. When we take 3 wire coils and make a triangle and put this little bar motor magnet in the middle, N over S, and use 3-phase power, UVW, this little bar magnet spins quite nicely by the rotating magnetic field and VW torque, and that's all we need, just a single dipole. However, when we go to 6 wire coils and put a series of magnets in the middle, you can have them 2 ways. You can have a single dipole, you can have 2 N's out or 2 S's out. You can do it both ways. However, here we have 2 S's out, which is a good arrangement. And you can spin it up somewhat using the rotating magnetic field, UVW, UVW. It'll spin anti-clockwise. These poles will follow the field around. However, the torque is a lot greater if we put 2 more magnets on the outside, and they can either be all 4 S poles out, or they can be 2 S's and 2 N's. And one way it spins anti-clockwise, the other spins clockwise. And that 6-4 arrangement gives you a lot more torque than 6-2, because not only do you have the rotating magnetic field, but also you have something else 90 degrees away called VW torque, where there's a big torque from the second magnet.